In the first video, we introduced the triangular numbers, and we also gave a formula for any triangular number, Tn. Right here, the subscript n represents the position of the triangular number in the sequence. So the formula that is mentioned in the first video is this. The nth triangular number equals n times n plus 1 over 2. So if you plug in different integers, whole numbers for n, you're going to get a list of triangular numbers. Actually, this formula can generate all the triangular numbers, but we did not prove it in the first video. So in this video, we're going to prove this. So first, we're going to construct a shape. We're going to put the two triangular numbers together. So by the formula or by the shape we talked about in the first video, we know the first triangular number is 1, the second triangular number is 3, and the third triangular number is 6, and so on. So we're just going to do the first 3 and try to find a pattern. So the first triangle has 1 dot. I'm going to put 2 of them together. So this dot represents the first triangular number. I'm going to put another dot to represent the second triangular number. And so that's two first triangular numbers put together. Now for the second case, second triangular number, we know we have 2 rows. Normally we will put 1 dot on the top and then 2 dots on the bottom, but we're going to do it backwards. So I'm going to put 2 dots on the top, and the second row I put 1 dot. So second triangular number has 2 rows, 2 dots on the top and 1 row on the bottom. And I'm going to put because we want to always put 2 triangular numbers together to form shape. So I'm going to put another dot in the first row and 2 dots in the second row. And we created these 2 triangular numbers. If we join these 3 dots together, that's exactly the second triangular number. And if we join these 3 dots together, and that's also the second triangular number. So we can see that this shape with 3 dots on top, 3 dots on the bottom, you can decompose it into 2 triangular numbers. They're both second triangular number. Now for the third triangular number, we put 2 of them together. So we have 3 rows. The top 3 dots, the first row, second row 2 dots, then third row 1 dot. So that's our that's the third triangular number. Now I'm going to put another one and underneath it, and I'll put 1 dot in the first row, 2 dots in the second row, 3 dots in the third row. And if you join these dots, you can see that's exactly the third triangular number. Okay, so you can, if we keep following this pattern, and when we have nth Tn, which means n dots on the top. What is n? We don't know what n is. Could be 10, could be 50 or 59 or 100. So we cannot really draw exactly how many dots on the top because we don't know exactly what n is. So what we can do is we're going to use these little dots to represent all the dots we omitted and draw the last one. So although I only draw 5 dots here and plus these 3 little dots, but it depends on how many little dots are here. It doesn't mean really I only have 3 dots here. These represent all the dots I did not put in here. So for example, if n is 10, and then I should have 10 dots in the first row, but I only drew 5 of them. So these little dots here represent the other 5. But if n is 100, I drew 5 dots here. These little dots will mean the rest of the 95 dots. So because in the general case, we don't know, we have no idea what n is, so that's all we can do. to use some little dots to represent the dots we didn't draw. So we're going to follow this pattern and continue to draw more dots. So the first row, this is our first row. We have, remember, we have n dots. So we have n dots. Be careful, it's not just 5 dots. And or some students might think it's 5 dots plus these little 3 dots. We get 8 dots. That's not right. We actually, these 3 dots represent all the dots we didn't draw. Okay, the second row, because we try to make a triangular shape, so we're going to have n minus 1 dots. So we cut everything. We're missing 1 dot right here. So we have n minus 1 dots. In the third row, we're going to have n minus 2 dots because we subtract 1 dot from the previous. And we have to keep doing this until we go to the very bottom, the nth row with only 1 dot. Okay, I'm going to use this little 3 dots to represent. Maybe I should change the color so we can tell better. So I'm going to use the black color to represent the dots we didn't draw. And the dots we didn't draw, the dots we didn't draw. And these, okay, so that's how we construct and more dots here we didn't draw. And okay, so that will give us a triangular number, which represents the nth triangular number. The top row has n dots, second row n minus 1 dots, and n minus 2 dots, and so on, all the way to go down to 1 dot. So we can use like little dots, 3 dots, to represent general case. So similarly, we're going to put another one underneath, another Tn. So the first row, 1 dot. So this is the first row, 1 dot. Second row, we got 2 dots. So we're going to put 1 below and right here. And then we have 3 dots. And so on, and then continue. So I should use black color to represent the dots we did not draw. So we continue this pattern, and we go down to the last row, which should have m dots. So 1, 2, 3, and so we're going to use the black color to represent the little dots. Okay, so we have right here, and the third row we have 2 dots, second row 2 dots, third row 3 dots, and the last row, nth row, we got n dots. And the bottom, all these dots on the bottom also form, sorry, didn't draw it very well, Tn, another Tn. So that's a Tn. The top is another Tn. Okay, so this is the general case we care about, but we draw the first 3 little cases, specific cases, to help us to understand the general case. But why we need to prove is a general case. So I'm going to look at the shape. So all these 2 triangular shape put together, we get first row n plus 1 dots, because from here to let's use a different color. From here to here, we have exactly the top row of the first triangular number. We got n dots, and plus we added another dot right here, so plus 1. We get n plus 1 dots in the first row. So the entire first row, combining both triangles, we have n plus 1 dots. And the second row, you can see if you add n minus 1 plus 2. What's n minus 1 plus 2? N minus 1 dots in the first triangular number plus 2 in the second triangular number. Simplify that, you still get n plus 1 dots. And similarly, you can do the third row, which has n minus 2 dots in the first triangle and in 3 dots in the second triangle. You still get n plus 1 dots. So you can see this is exactly every row has n plus 1 dots, but how many rows do we have? And we have, you can see, we have 1, 2, 3, dot, 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 we have n rows. So this shape consisted of these two triangles, has n, if you think about it, has n plus 1 columns and n rows. So if you think about it, if we draw a rectangle to represent it, the length is n plus 1, the width is n. And how do you find the area, which represents the number of dots in here? That should be n times n plus 1. So how many dots are in these two triangles? By looking at the rectangular shape, we know that should be n times n plus 1 dots. And these should be, all these dots are formed by two triangular numbers. So if you add Tn and another Tn, 2Tn, they should add up to all the dots in this rectangular shape, which consists of exactly n times n plus 1, these many dots, all these many dots. Okay, and if we divide both sides by 2 using algebra, we get exactly divide by 2 and divide by 2. The right side, 2 cancels 2. That gives us n, Tn. And the left hand side is exactly n times n plus 1 over 2. So we proved our formula for triangular numbers. When you do the homework, the second homework problem, you don't really have to use the proof, or you don't have to prove it. You can use this formula. So what's the formula? Well, we did prove Tn equals this, but how do we prove this one here? Because from the definition of triangular numbers, how do you get nth triangular number? You put a first row 1 dot, second row 2 dots, third row 3 dots, and the nth row you put n dots plus all those dots we didn't write here. And the left side is exactly Tn. So what's Tn? If we replace Tn with 1 plus 2 plus 3 plus dot 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 plus n, that should be equal to n times n plus 1 over 2. So at the same time, we proved this common formula that we use in calculus class a lot. And when we learn integrals and when we calculate Riemann sum, we have to use this formula sometimes. So when you do the homework, you can use this formula directly. When you add 1 up to n, you will get n times n plus 1 over 2. But you don't need to prove it.